Here, and today I'm going to be doing Unit 9, Note 7. So we're going to be talking about simplifying rational expressions, but they're only going to be with monomials and factors. So our learning target for today is that we can simplify rational expressions. So let's go ahead and let's take a look. So to simplify a rational expression, you must eliminate any common factors in the numerator and the denominator. So that's what we're going to be doing today with monomials and factors. Now when we do it with monomials, we need to cross off overlapping letters. And when we do it with factors, we need to cross off overlapping factors. So let's go ahead and let's take a look at what that would look like. So this is stuff you've actually done before. We did it in Unit 3 and we actually reviewed it earlier in this unit. So when you have 2x squared, remember that's the same as 2x times x divided by x. So what I'm going to do is I'm going to cross off my overlapping x's and I just end up getting 2x for my simplified version. So that's the simplified version. But you'll notice in the directions that it also says to state any excluded values. So even though we don't have a denominator in our simplified version, we need to look at the beginning when we had an x on the bottom. So our excluded value needs to come from that original problem. So our excluded value is that x cannot equal 0. So really all I did was set that denominator equal to 0, and it just so happens that it's just x that cannot be equal to 0. Taking a look at number 2, so we have 4a cubed, so that's the same as 4, and then having 1, 2, 3 a's on top, and 1, 2 a's on the bottom. So I'm going to go ahead and cancel out my a's. And left on top is 4a. So that's my simplified rational expression. Now I need to calculate out my excluded value. So I like to abbreviate it EV. So my excluded value is that a squared cannot be equal to 0. Well, right now that doesn't exactly tell me what cannot be equal to 0. So think about it this way, okay? So a squared is the same as a times a, and that cannot be equal to 0. Well, the only way that a is going to multiply to 0 is if a is equal to 0. So if you ever have a letter raised to an exponent, then that means that that letter cannot be equal to 0 for your excluded value. That letter cannot be equal to 0. So let's take a look now at number 3. So for number 3, oh hey settings, thanks for coming by. Alrighty, I'm done with you. Okay, there we are. So let's go ahead and let's take a look at number 3. So for number 3, we have 6 and then we have 2 a's on top. So I'm going to write those 2 a's on top. And then we have 1, 2, 3, 4 a's on the bottom. So I'm going to go ahead and cancel what I can. So I notice that it's only 6 that's left on the top. And on the bottom, I have a times a. Well, a times a is a squared. And that a squared needs to be written on the bottom because that's where those leftover a's were located. Okay, so next what we need to do is we need to find our excluded value. So I'm going to take a look at my original. So for my original, I get that a to the 4th cannot be equal to 0. And again, I'm talking about my excluded value. Now remember that the only way that a times a times a times a cannot be equal to 0 is if a is not equal to 0. Okay, so that's our excluded value for this one, and you need to do both parts on every single problem. Taking a look at number 4, so I have 3q to the 6, so I'm going to have 1, 2, 3, 4, 5, 6 q's on top, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 q's on the bottom. So I'm going to go ahead and cancel out. Oops, that one got twice. So I canceled all of those, and I have 3 q's left on the bottom. So I have 1 3 on top and 3 q's on the bottom. Well, q times q times q is going to give me q to the 3rd. So that right there is your simplified rational expression. Then I need to do my excluded value. Well, for my excluded value, I'm going to look at my original bottom, which is q to the 9th. So q to the 9th cannot equal 0. Okay, well the only way that q times 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 q can multiply to 0 is if q is not equal to 0. So again, our excluded value for that one is that q cannot be equal to 0. So let's take a look at number 15. So the first thing I want to do on number 15 is to reduce the fraction. 14 divided by 7 is 2. And then I have 2 x's on top and 5 y's. And then on the bottom, I have 2 x's and 2 y's. So I'm going to go ahead and I'm going to cancel those out. So I can cancel out the 2 x's, I can cancel out the 2 y's. So left over on top, I have 2, And then also left over on top is y times y times y, which is y to the third power. Oh, there should be 3 y's. Whoops, so those cancel. It should be y to the second power, excuse me. So that's our simplified rational expression. Now we need to calculate out our excluded value. So for our excluded value, we're saying, okay, 7x squared y cubed cannot be equal to 0. So what I'm going to do is I'm going to split that up. So 7 cannot be equal to 0. Well, no duh, that's never going to happen. So that one doesn't even matter. X squared cannot be equal to 0, and y cubed cannot be equal to 0. So the only way that x squared is going to be equal to 0 is if x is equal to 0. So we get that x cannot be equal to 0, and the only way that y cubed is going to be equal to 0 is if y is equal to 0. So here are your two answers, that x cannot be equal to 0 and y cannot be equal to 0. Next, let's take a look at number 6. So for number 6, we're going to go ahead and cancel that out. So we have 5 over 10. Both 5 and 10 are divisible by 5, so we're going to reduce that to 1 over 2. Then I have 1, 2, 3, 4 x's on top, and 1, 2, 3, 4, 5, 6, 7 y's. And on the bottom, 1, 2, 3, 4, 5, 6 x's, and 1, 2, 3 y's. So now I need to go ahead and cancel some stuff out. So I'm going to cancel out 1, 2, 3, 4. Okay, and I have 2 x's left, and then 1, 2, 3 y's cancel, and I have 4 y's left on top. So up top, I have y to the 4th. On the bottom, I have 2, and x times x is x squared. So that is your final answer for number 6. Now let's take a look at our excluded value. So for our excluded value, we're going to take our original bottom, which is 10x to the 6th, y to the 3rd, and say that that cannot be equal to 0. Well, 10 is never going to be equal to 0. So we know that x to the 6th cannot be equal to 0 and y to the 3rd cannot be equal to 0. Well, the only way x to the 6th is not going to be equal to 0 is if x is not equal to 0, and same thing with y. So that right there is your final answer for number 6. Let's take a look at number 7. So here we have, we need to do some multiplying first on top. So when you multiply monomials, you're going to multiply the coefficients and you're going to add the exponents. So let's go ahead and let's do that. So we're going to take negative 3 times 4, which is negative 12. When you multiply x squared times x to the 5th, you add those exponents and you get x to the 7th, and that's divided by 9x to the 6th. Well, take a look at the fraction negative 12 divided by 9. Negative 12 and 9 are both divisible by 3, so you end up getting negative 4 over 3. So then we're going to have 7 x's over 6 y's. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So now we need to go ahead and cancel some of that out. So we can cancel here, 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 and here. So we're left with negative 4 and just an x on top, and then divided by 3. So let's go ahead and take a look at our excluded value. So for our excluded value, we get that 9x to the 6th cannot be equal to 0. Well, 9's never going to be equal to 0, so we just need to worry about when x to the 6th is going to be equal to 0, and that's simply when x is equal to 0. So our excluded value is that x cannot be 0. So let's take a look at number 8. So for number 8, you're going to multiply negative 4 and negative 2, and that's going to give you 8y to the 9th divided by 4y to the 8th. Well, 8 divided by 4 is simply going to be 2. And then you have 9y's, and then you have 8y's on the bottom. Well, since I have 8y's on the bottom, they're all going to cancel out except for 1y up top. So then my final answer is 2y. Then, for my excluded value, I need to see when 4y to the 8th is going to be equal to 0 and throw that one out. Well, 4 is never going to be equal to 0, so we need to figure out when y to the 8th is going to be equal to 0. And that's only when y is equal to 0. So that's our excluded value. Now let's take a look at ones when we have actual factors. So when we have factors, what we need to do is cross off our overlapping factors. So I can actually cancel out x plus 3 over x plus 3. So that does cancel out my top. So what I do is I write a 1 as a placeholder, and then on the bottom I have x minus 1. So that's my simplified rational expression. To get my excluded value now, I need to figure out when x plus 3 3 times x minus 1 is equal to 0, and throw those values out. So what this is here is a zero product property problem. So what I'm going to do is I'm going to put x plus 3 and say that cannot be equal to 0, and x minus 1 cannot be equal to 0. So here, subtract 3 from both sides, and you get that x cannot be negative 3. Here, add 1 to both sides, and you get that x cannot be 1. So those are your excluded values for number 9. Taking a look at number 10, we want to cancel out our x to the fourth. Again, that cancels out the top, so I'm putting 1 as a placeholder divided by x plus 2. Then, for our excluded values, what we want to do is we want to set our original denominator equal to 0. So x plus 4 times x plus 2. Or is it minus 4? It is minus 4. X minus 4, come on, times x plus 2 cannot be equal to 0. So then, x minus 4 is not equal to 0, and x plus 2 is not equal to 0. So when you solve for x on the first equation, here you're going to add 4 to both sides, so you get that x cannot be 4. Here, subtract 2 from both sides, and you get that x cannot be negative 2. So those are my two values. X cannot be 4, and x cannot be negative 2. So let's take a look at number 11. So again, we need to cancel some factors out here. So I'm going to cancel out my x plus 2 and my x plus 2. Well, when I cancel those out, I'm left with x minus 3 on top divided by x minus 4. And actually, since we're not multiplying anymore, you don't need those fractions or the parentheses. So you can just do x minus 3 divided by x minus 4. And now I need to calculate out my excluded values. So I'm going to take x plus 2 times x minus 4 and say, okay, that cannot be equal to 0. So what I'm going to do is set each of those factors to not equal 0. So here, what I want to do is solve each of these for x. So I'm going to subtract 2 from both sides, and I get that x is not equal to negative 2. Here I'm going to add 4 to both sides, and I get that x is not equal to 4. So that right there is our excluded values for number 11. Same thing for number 12. I'm going to cancel out those x minus 2's. And then left on top, I just have x plus 4 divided by x minus 6. Again, I don't need those parentheses because I'm not multiplying. Then I want to take my original denominator and set it equal to 0. So x minus 6 and x minus 2 cannot be equal to 0. So x minus 6 cannot be equal to 0, and x minus 2 cannot be equal to 0. So then I get that x cannot be 6 or 2 when you add those two over to the other side. Lastly, let's take a look at 13 and 14. So for 13, I want to cancel out my factors. So I can cancel out x plus 3. And then what I'm left with is x minus 2 alone on top, but then I have x plus 2, x plus 4 being multiplied on the bottom. Now for me to have an entirely multiplied, simplified rational expression, I need to actually re-multiply those two together. So I do that using the box method. So I have x plus 2, x plus 4. So I'm going to multiply x times x is x squared, 2 times x is 2x, 4 times x is 4x, and 2 times 4 is 8. So then I'm going to write out all those terms. So I have x squared plus 2x plus 4x plus 8, and then I get x squared plus 6x plus 8. So now what I want to do is I want to write that back into the original expression. So what I end up getting is x minus 2 divided by x squared plus 6x plus 8. So that is my simplified rational expression. Now I need to calculate out my excluded values. So for the excluded values, I need to take the original bottom, which is x plus 2, x plus 3, and x plus 4. And that cannot be equal to 0. So x plus 2 cannot equal 0, x plus 3 cannot equal 0, and x plus 4 cannot equal 0. So now we can go ahead and we can subtract those out. So what we're going to do is we're going to subtract 2, so we get that x cannot be negative 2, negative 3, or negative 4 for those excluded values. Let's take a look at number 14. So for number 14, again, we want to get rid of our overlapping factors. So I'm going to get rid of x minus 3. So I have x plus 4 left over on top divided by x minus 4, x plus 6. Now before I can call this fully simplified, I have to multiply out that bottom. So I'm multiplying x minus 4 and x plus 6. Well, x times x is x squared. Negative 4 times x is negative 4x. 6 times x is 6x. Negative 4 times 6 is negative 24. So we have x squared minus 4x plus 6x minus 24. So then I can go ahead and I can add those middle two. So x squared plus 2x minus 24. So now I want to rewrite out my rational expression. So originally on top I had x plus 4. And then on the bottom I'm going to have x squared plus 2x minus 24 once I've re-multiplied that out. And that right there is my simplified rational expression. The last thing I need to do is calculate out my excluded value. So I'm taking x minus 4 times x minus 3 times x plus 6, and I'm saying that that cannot be equal to 0. So each of these factors cannot be equal to 0. And now we're going to solve for x. So on the first one, we're going to add 4 to both sides. So we get that x cannot be 4, 3, or negative 6 when you add all of those equations. So that concludes your note video for today. Go ahead and show me a completed note sheet once you are done. Thanks for listening.